Next example on the Newton's action. Next example on the Newton's forward difference interpolation formula. So the table is given. The values of x. The first row contains the values of x, and the second row contains the values of function y or of x. And we have to find the value at 1.45. So 1.45 is what lies between 1.4 and 1.6. That is, this value is middle to the table, and that's why we can use Newton's forward interpolation formula as well as Newton's backward interpolation formula, because when we use the Newton's forward interpolation formula, that is the note is that this formula is useful for interpolating the value of fx near the starting of the set of values. And similarly, the backward interpolation formula, Newton's backward interpolation formula, is useful to the end of the given values, interpolating the end of the table. And also when these two formulas are used, when these values of x are equidistant. But here in first problem, the values are equidistant, that 140, 150, 160, 170. The distance is 10, which is 10. But what is the question? We have to find the value at 142, and it is at the beginning of the table. That's why here the Newton Raphson method is powerful. We can also use Newton's backward difference formula, but there is some big calculations or huge calculations. That's why if the value is at the beginning of the table, the value at where to interpolate is at the beginning of the table, then use Newton's forward difference interpolation formula. And if the value is at the end of the table, then use Newton's backward interpolation formula. And for both the formulas, the value of x must be equidistant. If the values are not equidistant and we have to interpolate the value, then use Newton's use Lagrange's interpolation formula. That is the third formula. When we use the Lagrange's interpolation formula, the values of x are not necessarily equidistant. That is, may or may not be equidistant. In that case, we can use Lagrange's interpolation formula. So here the value is at the middle of the table, that 145. The value is at the middle of the table, and therefore we may use Newton's forward interpolation formula or Newton's backward interpolation formula. So here the problem is by using Newton's forward interpolation formula. So we have to prepare the forward difference table, because we have to apply the Newton's forward interpolation formula, Newton's forward difference interpolation formula, and we have to find the value at 145. The value of finding at 145 using this table is called interpolation. This procedure is called interpolation. That is the problem of interpolation. And the values of x are equidistant. That 1 and 1.2, the distance is 0.2. 1.2 and 1.4, the distance is 0.2. Similarly, the distance of between each two values of x is 0.2. And that is the values of x are equidistant. So the Newton's forward interpolation formula, Newton's backward interpolation formula, as well as Lagrange's interpolation formula is applicable for this problem. But if the values are equidistant and there is no instruction in the problem that apply Newton's forward, Newton's backward, or Lagrange's, that means if we have to decide the use formula, then if the value is at the beginning of the table and the values are equidistant, then use Newton's forward interpolation formula. If the values of x are suppose equidistant and the interpolation is at the end of the table, then use Newton's backward interpolation formula. And if the values of x are not equidistant, then use the Lagrange's interpolation formula. So we will solve this problem by using Newton's forward interpolation formula. And so we prepare first the forward difference table. So this is the forward difference table. That is the first row, first column contains values of x. So we are given six values of x as well as y. And that's why the table end at the last column of the table is what? Probably delta raised to 5y. But here at the column delta cube, all the values are same. And so no need to find the further columns. If these values are not same, then all these entries in any column are not same, then the table is continued at delta raised to 5y. Why this table terminated at this place, at this column? Because at this, if you observe the entries in this column, in this column delta cube, then all the entries are same. So no need to find the further terms, because if you find further terms here, delta raised to 4y column, what are the entries in this column? 0, 0. The next column, if you find next column, then the entry is 0. So no need to find the further columns if the values of delta cube or in any column are same. So this is the forward difference table. The first column contains the values of x, the second column contains the values of y, and then third column delta y, delta square y, or write fx. Then delta cube y, delta raised to 4y. And what is the increase in this third column? This number minus this number is entry at this place. This number minus this number. So similarly, this minus this at this place. And we know that if the table is forward difference table, then these values are important. That is, this is the f of a. This is delta f of a. This is delta. This point, first point is a, and this is delta square f of a, delta cube f of a, and all the remaining are what? Are 0. That is delta raised to 4 f of a, delta raised to 5 f of a are 0. So here a is what? A is 1.0. That is 1. That is the first value of x, and this is f of a. Okay, and what is the h? H is the common difference is 0.2, and then find what? U. What is u? X is what? X is the value 1.45. That is, you have to find the value of y or fx at 1.45. That is x, and a is what? The first value of x, and h is what? Common difference is 0.2, and therefore u is what? The formula for u is what? X minus a divided by h. So x minus first value of x divided by h is the formula for u. And if in the next interpolation formula, that is in the next Newton's backward interpolation formula, what is the value of u? In that formula, u is x minus last point divided by h. Here, what is u? X minus first point divided by h is u. And then we have the x, u is 2.25. Then write the Newton's forward interpolation formula, Newton's Gregory forward difference interpolation formula. This is the general formula. F of x is equal to f of a plus u delta f of a, u minus 1 by 2 factorial delta square f of a, then u minus 1, u minus 2 divided by 3 factorial delta cube f of a, and the next term is what? U minus 1, u minus 2, u minus 3 divided by 4 factorial delta raised to 4 f of a. But the delta raised to 4, if you observe this table, then delta raised to 4y, delta raised to 5y, all are 0. So no need to write the further terms. Here the terms are terminated. The terms of the forward interpolation formula are terminated at this place, because all the remaining differences are further higher order differences are 0. And then substitute the values of f of x, that is x is 1.45. That is, you have to find the value of f at 145. So x is 1.45. Then f of a from the table is 0. Then the value of u is 2.25. Then delta f of a. So if you observe the table, this value is delta f of a. this value is delta square f of a. This value is delta cube f of a. So substitute all these values. That is the value of u and delta f of a, delta square f of a, delta cube f of a, and add and subtract all these numbers by using calculator. We have the value 0.04612. This is the value. So if we observe the table, then 0.04 is the value at 145, 1.42, 1.45. Okay, so here is the 1.45. So if you observe, now the value is 0.04. Okay, so next problem, similar problem. Lx represent the number of persons living at the age x in a life table, and find accurately Lx for x is equal to 35, and given is what? L20 is 512, L30, L suffix 30 is 390, L40 is what? Is 360, and L50 is what? 24. So Lx represents the number of persons living at the age x in the life. That is what is the first column in the forward difference table? The first column is x, and what is x? X is 20, 30, 40, and 50. This is the first column x, and the corresponding values of Lx are what? And at x, at 20, the value is what? At 20, the value of Lx is what? 512. So, and then the value at 30 is 390. So, second column is what? The values of Lx. So, x and Lx. Okay. So, and then prepare the, suppose Lx, instead of Lx, we can also use y or fx notation. Then delta square, then third column is delta cube. And prepare the forward difference table. Okay. So what is the question? We have to find the value of Lx at 35. That is, here is 35 at the middle of the values of x, and so we apply the forward difference formula or backward difference formula. Newton's forward difference formula or backward difference formula. So x, that is, we have to find the value at 35. So x is 35. A, that is the first value of x, is 20. H is the common difference. So the difference between these values 20, 30, 40, 50 is about 10. That's why h is 10. And then u is what? X minus first point divided by x. That is 35. That is where to find the value of 35. So that x is 35 minus 20 divided by 10. That is common difference h. And the value is what? Value of u is 1.5. Then write the general formula. Right here L35 or f of x. Instead of L35, you can use the notation f of x. That is f of 35. Is what? F of a plus u delta f of a. This is the general formula. U minus 1 by 2 factorial delta square f of a. Then u minus 1, u minus 2 by 3 factorial delta cube f of a. And if you observe the table, then the table, the values of x are in 4 number, and so table is terminated at delta cube. The last column is delta cube, and all the further higher differences are 0. And then by using the table, find the substitute the value of f of a. So the table, these values are important. The underlying values, that's 5, 1, 2. This is delta f of a. This is delta square f of a. Delta cube f of a. Substitute all these values and calculate. We have the answer 390. So what is the answer corresponding to 35? 390. So actually these are the number of peoples, and that's why the nearest integer to answer is 390.06. But number of persons are in integer, in a natural number. That is, number of persons are not half, not 1.5, and that's why the nearest number to 390.06 is what? 390. The nearest natural number. Nearest natural number. So the answer is 390. Next problem on the same formula, that is Newton's forward difference formula. The table is given. Find the number of men getting wages between 10 to 50. So how many men get wages between 0 to 10? 9 men getting wages between 0 to 9, 0 to 10. Then 10 to 20, then the number is 30. Then 20 to 30, 35. And then 30 to 40 is 42. That is the number of men getting wages between rupees 30 to 40 is 42. And we have to find the number of men getting wages between 10 to 50. If you find the number of men getting wages at 50 and the number of men getting wages between 0 to 10, that is up to 10 is 9. And if we determine the men getting wages up to 15, then the subtraction gives the number required answer. So the first column is what? 0 to 10. So the table is, this given table is converted to this table. That is wages, getting wages less than 10, less than 20, less than 30, less than 40. So how many men getting wages less than 10? 9. 9 getting the wages between 0 to 10. That is less than 10. The frequency is what? Is 9. Then 10 to 20 are 30. So these are 30 number is what? Is the number of men getting wages between 10 to 20. So how many men getting wages less than 20? 39. Because these 9 also getting wages between 0 to 10 means less than 20. And these 30 also getting wages between 10 to 30. And so total men getting wages below 20, less than 20 are 39. Similarly, the wages less than 30 is what? The addition of these three numbers, 74. And the number of men getting wages less than 40 are what? Addition of all these four numbers. So in this example, the values of x and values of y are not given in the table, because we have to find the number of men getting wages less than 50. And x is 50. Prepare the forward difference table. And then x is 50. A means first value is 10. H is common difference between this is 10. And then u is what? X minus a divided by x. So 0.5 is. And then write the general formula of Newton's forward difference. This is the general formula. And then substitute the values. X is 50. That is why to find the value at 50. So value is what? 23.5. And so number of men who obtain wages between 10 to 50 is what? 23.5 minus 9, that is 14.5. And the nearest integer is what? 15, right? 14. 14 or 15, both answers are correct. So what is the answer? It's 15 or 40. So number of men obtain wages between 10 to 15. So how many men getting wages between 0 to 10, that is below 10, are 9. And the number of men getting wages less than 15 are 23.5. And that's why their subtraction gives the answer, that number of men who obtain wages between 10 to 15. Next problem on the same method. The problem is find cubic polynomial which takes the following values or which fits to this data. That is, we have to find the cubic polynomial. So we can also find the polynomial that fit to the data by using Newton's forward, backward, and Lagrange's, by using all these three methods. And the values of x are equidistant, 0, 1, 2, 3. So we can use Newton's forward or backward. So using Newton's forward method, prepare the forward difference table. So this is the forward difference table, the values of x, y, and then delta, delta square, delta cube. Then take a as a 0, that is the first point. H is common difference is 1. And then take u as x minus minus a by h. So what is x in this problem? X is x in this problem. That we have to find the cubic polynomial or polynomial which fits to this data. And that's why x is x. In the previous problems, x is what? X is the number. But in this problem, x is x. That is, we have to, the problem is different than the remaining problems, previous problems. This is the find cubic polynomial which takes or which fits to this data. And so x is x. X is not number. And a is the 0, that is the first value of x divided by h is common difference. And so u is x. And then write the Newton's forward interpolation formula. F of x is equal to is what? F of a plus u. So right here f of x instead of u plus h. F of x is equal to f of a plus u delta f of a plus u minus 1 by 2 factorial delta square f of a, and so on. The table is terminated at delta q. So write up to the terms delta q. If the table is terminated at the delta raised to 4, then write one more term. What is the next term? U minus 1, u minus 2, u minus 3 divided by 4 factorial delta raised to 4 f of a. And then substitute the values of x as x, and the value of f of a is what? Is 1. Then value of delta f of a is 1. And u is x, so substitute u and all the values of delta f of a, delta square f of a, delta cube f of a, we get this answer. So observe this fx is what? 1 plus 6x minus 7x square plus 2x cube. This is the polynomial of degree 3. The question is find the cubic polynomial. So this polynomial is what? Is the best fit to this data. That is, if we substitute x is equal to 0 in this polynomial, then we get the answer 1. Value answer of 1 fx is what? 1. If we substitute x is equal to 1 in this polynomial, in this value of fx, then we get the answer 2. If we substitute 2, then we get the answer 1. And if we substitute x is equal to 3 in this table, in this value of fx, we get the answer 10. So this is the polynomial which takes the following table, which takes the given values. Then the next problem, again, find the number of students who obtain less than 45 marks. So this is the table that the first row denote marks, and the second one is what? Number of students. So the number of students obtain marks between 30 to 40 are 31. So, and the marks between 40 to 50 are 42. And marks between 50 to 60 are 51, and all the remaining values. So, and we have to find the number of students who obtain less than 45 marks. So, first column is what? The first column is below 40, that is the marks below 40, below 50, below 60, below 17, below 80. And how many students obtain marks below 40? 31 obtain marks below 40. Then how many students obtain marks below 50, that is less than 50, are 31 plus 42. Because these students 31 obtains marks between 30 to 40 means these students 31 students obtain marks between less than 50. That's why the addition of these two numbers is at this place. Then obtain marks between below 60. So how many students obtain marks below 60? 31 plus 42 plus 51 is the 124. Then obtain marks below 70 are 31 plus 42 plus 51 plus 35 at this place. And then the number of students obtain marks below 80 are what? The addition of all these numbers. That is 190. And then find the remaining columns, that delta fx, delta square fx, delta cube fx, delta raised to 4 fx. Okay, and these values are important. These underlying values are important. Then write the Newton's forward interpolation formula, general forward interpolation formula, up to delta raised to 4 f of a, because the last column is what? Delta raised to 4 fx, or delta raised to 4 y. And then what is u? What is f of a? What is x? X is 45. X is 45. A is what? 31. And h is what? H is 10. So find u. That u is what? X minus a divided by h. X is 45. A is 40. H is 10. Then find value of u by using formula x minus first point divided by common difference. and it is 0.5 or 1/2. Then substitute all these values in the formula. We have the answer 47.86. And also this is the what number of students, and this answer must be integer. So what is the nearest integer to 45.8? 48 is the nearest integer or nearest natural number. So what is the answer? Final answer: 48 students obtain less than 45 marks. 48 students obtain less than 45 marks. How many students obtain less than 50 marks? 73. And how many students obtain marks less than 31? So answer must be between 31 to 73, and that is the answer is what? 48. So these are some exercise or problems for homework. So this is the values of sine 45, sine 50, sine 60. So what is the first column? Is 45, 50, 55, 60. This is the first column of our forward difference table, and then these values are the values of fx, that is second column. Then use and then prepare the forward difference table and solve the problem, that is, and the value find value at 53. Okay, and similarly we have to find the value in the second problem at 218. So 218 is at this place, 218, and the value of h is 50 in the second problem, is 100. Then write the prepare the forward difference table and write the general formula of Newton's forward interpolation formula, and substitute the values. We get the answer. The answers are also given. Similarly, this problem cubic polynomial. So use x is equal to x in this problem. So again, then same problem. This is also where to find the value at 1895. That is the population of the population in the decimal census. So this is the population given in the decimal census, and then find the population for year 1895. So use the Newton's forward interpolation formula. This first row becomes a first column, second row becomes a second column of forward difference table, and then interpolate the value. And these are also same problem. This first row as a first column, second row as a second column, and then value at 0.24. 0.24 is lies between this 0.2 and 0.3 by using Newton's forward interpolation formula. This is the area of circle of diameter 82. Where to find the area of circle 82 of diameter 82 from the following data. Okay, that is we are given the first row as a diameter and the second as area. So the first column becomes a first row. First row becomes a first column in the forward difference table. Second row is the values of fx. So this is x. These are the values of x. These are the values of y or fx. Then prepare the table and solve the problems.